Welcome to September's Leetcode challenge. Today's problem is sequential digits. An integer has sequential digits if and only if each digit in the number is one more than the previous digit. Numbers like 1, 2, 3, 2, 3, 4. Now we want to return a sorted list of all those integers in the range of low, high, inclusive. So we're given low and high, and we're going to return the sequential digits within that range. Now there's some constraints. We need to make sure that the number is 10. It's going to be minimum amount of 10 and the maximum number of 10 to the ninth power. I'll give you a couple hints here to generate all the sequential digits given range. Yeah, obviously, or do some recursion, things like that. But before we get there, let's just think about how we might go about generating these sequential numbers. Now, if we had 1, 2, 3, 4, 5, 6, 7, 8, 9. One of the things you should realize very quickly is this is the maximum number that we can generate. All right, and what's going to be the minimum number? Well, it's 12, right? That's the minimum number. So if we were to generate this in order, how would that kind of look? Now, if you just picture it, we can imagine like we have a range of 12 first. That'll be the first number that gets generated. Then 23, right? Then 34. Then 45, then 56, so on and so forth, all the way to 89. What comes after that? It's 1, 2, 3, right? Then it's 1, 2, 3. Then it's going to be 2, 3, 4, 4, 5, 6, so on and so forth. And then on the next sequence is going to be 1, 2, 3, 4, and then 2, 3, 4, 5. So one of the things I think that makes you quickly realize is there's actually not that many sequential digits within this range. In fact, there's only I believe it's 36, 45 or 36, I don't remember. But if that's the case, then it actually makes sense to just generate all the sequential digits and then return what's within this range. And really, recursion doesn't even need to take place here. It's just a nested for loop that we can use to do that, right? So as long as we have this string, this mapper thing that we can use, it could be a list as well, but as long as we have something here to generate, like, all right, how does our number look as we generate them sequentially? That's all that really matters, right? So I'm going to go with that approach first, then maybe I'll go through recursion. So let's call this a mapper. And what I'm going to do is say, all right, for the number of digits that we need, it's going to be at least 2, but we don't need to generate all of them, right? We just need to make sure that it's going to be within this low and high range. So with, let's say, digits for D in range of the length of low, or I should say the string of low, all the way to high. We'll say the length of string to high. And the reason I made it a string is length doesn't work on integers. We need to convert it to a string to know how many digits there are. And I'm going to actually have to add 1 there to make sure that we check all of them within this range. Now all we do is take from the sequence of I in the range of starting with the 0 index all the way to, well, it's 9, right? Yeah, I believe it's 9, but keep in mind that we need at least 2 digits, right? So it's actually going to be 8. So we need this to decrease every time this digit increases. So it's going to be 10 minus D, which is going to allow us to make sure that we don't get any numbers that don't fit in here. We don't get 7, 8, 9 and then put in 8, 9. Okay, we need to stop at 7, 8, 9. All right, so now we just have our output, and what do we want to append? Well, I guess we want to append from our mapper the I all the way to I plus D, right? And very quickly, actually, I'm realizing something here. We don't even need this output. Or what I mean is we could have, instead of creating all the numbers within this range and then checking, we could just make sure to break our loop as soon as we find that we've exceeded our high range. So what I'm going to do then is we will convert this into a candidate. We'll say we can make this a candidate, and this is going to be a string. Convert that to an integer, and we'll check. All right, if this candidate is lower than low, because that's possible right now. We don't know what this low number is in this loop. We just are checking the number of digits, right? So if it's less, then we'll just continue. However, if it's greater than high, then we need to break our loop immediately. And after that, we'll just append the candidate. It's going to be an integer. And that would be it. Just return our output after that. Now let me make sure this works. It should be 1, 2, 3, 2, 3, 4. Looks like it. And there we go. That's accepted. Now this is not recursion. This is just a nested for loop. And I think just to make sure we're thorough, we should go through how we might do this recursively. So let's think about that. If I was to do this recursively, like how would we build our list of sequential digits? Remember, there's only 36, right? So we know that 12 is the minimum, and then 1, 2, 3, 4, 5, 6, 7, 8, 9 is the highest. So probably if we were to do this recursively, we would just build up like 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 4, 5, and so on and so forth. And once we finish that, we should do this recursion. We can have this recursive function be in some sort of for loop. And that could be like 2, 3, start with 2, 3, then 2, 3, 4, 4, 5, and just continue on up until the last digit is 9. We'll break our recursion once the last digit we find is going to be 9. Okay, so let's try doing that. So what I'll do is create a list. This will be empty, and I'm going to make a function. It's called recursion. And what I'm going to have to do is pass in the starting digit. What are we on? Are we on 1? Are we on 2? Like, what do we start with? As well as the build, I guess we can call it path or the build. I'll call it a build. And we'll also pass in the list. And this is where we'll actually append our final digit. So if the build modular 10, meaning the last digit actually is 9, we can stop here. We can say, all right, just not break, and return and stop our recursion. Otherwise, let's think about this. I guess we recursively call with the start plus 1. No, that's not right. We keep the start. We would add to our build. We would say multiply by 10. Excuse me. And I suppose, I guess we would add start plus 1. Is that right? No, we wouldn't add plus 1 there. We would add plus 1 here. We would add start plus 1 so that this would become 2 now. And our build is building up, so it starts with like 10, and then it should be 12. Is that right? I think that's right. And really that, once we get through all the way to the end, then we could start adding it to our list, right? So let's try doing that. We'll say, okay, list append whatever we've built up, or actually I need to, since we're not going to backtrack, we're just going to append it here. And then we'll have to do this in a for loop to make sure that we do from 1, 2, 3, 4, 5, 6, 7, 8, 9, 2, 3, 4, 5, 6, whatever. For I in range of 1 through, I guess, well, we don't need to do not, I don't think we have to do 9, because that's, yeah, we can't do 9. So 9 would be 8, 9 would be one of them. So recursion I, that's the list. So let me just test this out and make sure that I got this right here. Oh, okay. If build equals 9 right there, the last digit. Oh, okay. So it looks like I need to plus 1. Let's return. I guess that is plus 1 then. That surprises me there. And see, already, like, I'm kind of hating this solution. This is like way worse. So why am I doing this? Well, okay, to be thorough, let's try to go through it. Okay, start plus 1, build times 10, start plus 1, build, append. Oh, yeah, I've got plus 1 there. Okay, there we go. Okay, looks like it's doing what I thought it would do. Now, one thing is we should probably sort this, right? Because rather than going through the entire low to high range, we don't really need to do that. We just need to go through these numbers and just return the ones that are within the range, right? So for, let's say, let's first sort this list, and then say for I in list, we'll say if I is less than low, then continue, kind of the same thing. If I is greater than high, then we could break, otherwise append to our output. So we'll have some sort of output here that we initialize and return the output. So let's see if this works. Uh-oh. What? Oh. Yeah, I have to run it, obviously. So wait, what am I doing here? For I in, I'm really sorry guys, I'm like just totally out of it right now. Length of, or I'm sorry, 129, do recursion, I list. Okay, there we go. So now we first do our recursion, get all the sequential digits, and then we will go through all of them and just add the ones within the range and then return that output. So let's make sure this works. And there we go. I hate the solution. This is way worse than mine, I think. Mine was a lot more intuitive and probably faster. So just to be thorough, I went through this recursion one, but I like my first one way better. So, all right, thanks for watching my channel. And remember, do not trust me. I know nothing.